you can share the streaming if you want. I think it's on the top of the image. So hello. Thank you everybody for coming. I think we will start the season related with what makes Groovy Groovy. We would like to thank Guillem, that is in the other side, and Alex, that is another co-organizer of the Java user group. And as some of you may know, I think I will do the presentation of the Java user group, and then I will pass the signal um, to Guillem. So I will try to find where is my presentation, and then okay. If something is wrong, please guys tell me, because I think it's the first or the second time I'm moving around, but I think it's really okay. So what we're doing right here right now is moving on the next step in order to organize different events in the Barcelona Java user group, and I think it will be a really interesting thing. So for any people that doesn't know anything about the Java user group in Barcelona, I will tell you who we are. And what we are is only a group of guys that based on Barcelona, and we like to discuss and focus on Java technologies. And we are people already curious about technology. That's it. That's it. I mean, nothing more, nothing else. And what we do, we made a lot of events, and we are already focused on different kind of formats of events. We are trying to keep the information and the events related to the developer community, and we are of course focused on Java, but not only in Java. So for us, it's really interesting. And what we are looking is people like people that is attending at this event, open-mind developers and great speakers like Guillem. And of course, we are looking for sponsoring and why not many contributors to the community. We have some links for the people that doesn't know anything about us. We have a main website, the Meetup, that is working really good. All the people can use the Meetup or even the Twitter for tweet something about it, if the event right now it works or not, or if the people has questions for Guillem, for example, could be a good point to answer it using Twitter or even in Google Plus or Google Groups. So go ahead. Sometimes I will only look for some passivos we made the last year. We made a lot of them. There are a few you can see here related with different technologies or frameworks and services. So if you want, we have a lot of them, and you can check it out in our website. And well, this will be our next season. Focus on Java and Java EE and the new batch module that is inside. It will be a really interesting talk by Roberto, another good friend of Alex. And I think will be a really interesting talk focused on what Java EE has in benefits or using batch services. So related with World of Warcraft, so maybe a really interesting thing. And yes, it will be online also. So maybe why not all the people around the world can listen it. So it will be another interesting thing. And that's it from our side. I would like to thank all the people that we was looking in the last season, in the last year. So we would like to receive your feedback, please. And that's it. So please go ahead and write. This is URL, and you can see a little form and see what do you think about the last season, if you like it or not. So there's only 2 minutes. So please go ahead. And that's it from our side. I would like to say hello to the new people and say hello to, of course, to Guillem, to thanks for all the time that we'll be bringing to us, and of course we will like every people that it will be interesting in joining our community. So that's it from our side. I would like to thank again Guillem, and right now I will pass the season and the thing of the season to Guillem, because that's for me. I don't have anything more than say the welcome to Guillem. So that's it.
Okay, thank you. I'm going. Okay, do you see the slides?
Yep.
Okay, and I'm going to put them in full screen. Do you still see them? All right. Okay, So let's start. So thanks a lot for inviting me. That's my pleasure to be here, even if it's virtually. And we'll be speaking about what makes Groovy Groovy. So
Sorry,
I'm Guillaume.
I
Yeah.
see your screen black, I think.
Okay. Let me see. So perhaps when I put that in full screen, it's not working. Let's see. Let's try again. Up. What do you see here? Is it? Do you see the slides?
No.
No. How can I put them?
I think
To
you need
make.
to share right now.
So when I screen, so let's see, because they are not in full screen.
I think because you need to choose to share your screen.
Yeah. So here you see the Keynote application. You see the slides, but not full
Yep.
screen, I guess, right?
Yep.
And when I do full screen, when I use the play button, now you don't see anymore?
Yes.
Ah. Well, I guess how am I going to do that?
Maybe you can try to just share your screen again. Maybe when you're in full screen.
Full screen, perhaps. Okay, let's see. Let me try. I can't go back to. Well, I'll go that way. Is it okay? Because I'm not really finding how to make it happy. So let me just start again, unsharing and sharing again. And okay, share. Is it still black that way, or is it better?
No, it is black.
Okay, well, so I'll go with the it's not the presentation mode, so you won't have the the little animations, but well, it's better than nothing, I guess. Okay.
Okay.
Okay, so what makes Groovy Groovy? So I'm Guillaume Laforge. I'm leading the Groovy project. I've been working on Groovy for the past 10 years now. It's been a while. So a few links. I'll give you the links to the presentation afterwards. If you want to follow me here and there. This is I'm working for Pivotal, and okay, let's go. So what Groovy is? Groovy is an open source project. It's an alternative language because the JVM lets you run alternative languages. Basically, it's not just Java. I lost my voice over the weekend, so if I'm coughing in the middle of the presentation, don't be too worried. I'll get through it. Groovy is object-oriented, so all you know from Java, I mean classes, interfaces, abstract classes, enums, etc. All those things are the same in Groovy, basically. There's one thing, though, is that in Groovy 2.3, we added traits to Groovy, which is a new object-oriented concept, which is like interfaces with a bit like default methods in Java 8, but it goes a bit beyond because it supports also state and other things. So it's like Java plus some other things. Groovy is also a dynamic language in the sense that we have runtime, which does the method dispatch at runtime. That's also one of the key aspects which brings certain very interesting features that we'll be seeing a bit later on in this presentation, like the Groovy builders, market builders, etc. etc. We'll be having a look at that later on. And it's also a language with a functional flavor because we've got closures, which allows us to put some logic into a function, like a JavaScript function, etc., or lambda in Java 8, and all the added methods enriching the JDK that Groovy provides, like on top of collections to do filter, map, reduce, that kind of things. So that what makes Groovy also a functional language. But although it's a dynamic language by its very nature, you can also do static type checking, providing the same kind of feedback as the JavaC compiler, like when you make a typo in a method name, or if you return something which is not of the right type, etc. And we can also do static compilation by passing the Groovy runtime, so as to have the very same performance as Java, because we generate more or less the same bytecode that JavaC provides when we enable static compilation. So the vision we've had when we created Groovy was that we really wanted to simplify the life of Java developers. Groovy was studied as a kind of superset on top of Java, because most of the Java syntax is also valid Groovy syntax. But that's also what makes it very easy to learn for Java developers, obviously. And it's got, so you don't see the animations, but never mind. It's got its own, so when I said earlier that we enrich the JDK, that's what we call the Groovy development kit. That's all the methods that we add to things like collections, strings, etc. Enriching, adding things like, let's say, find all method on collections to find all the elements that match a certain criteria, etc. Plus, beyond that, there are also APIs like a JSON module, an XML module, a SQL module, etc., which brings additional simplifications on top of existing APIs, or bringing new APIs, because it's a very pragmatic and practical language to get things done. It's also a language which is quite elegant in the sense that we were able to somehow hijack the syntax, the grammar, the syntax, to make things like that. This is a test specification using the Spock testing framework. And notice that we use labels, expect and where, to denote different parts of our test case. We've got an expectation, and the very nice part, I think, is the where block, where you have this wiki-like notation to say, okay, it's a data-driven test, because in turn it will replace the values of A, B, and C with the values that you see in each line of this wiki-like notation for a table. So it's pretty readable, and for those who've done data-driven tests with JUnit, it's way more readable than what you would do with something like JUnit. So it's also an elegant language. It can be as fast and as safe as Java, thanks to static type checking and compilation. And with the animation, it's not very readable. Let me remove that first. I'll show you that afterwards. This is the markup builder class. It's leveraging some of the dynamic aspects of the language, because the markup builder allows you to create arbitrary XML or HTML content. And actually, methods like HTML, head, title, body, div, p, etc. Don't really exist on markup builder. But those methods are intercepted by the runtime and are dealt with by the markup builder class, which is going to intercept those methods and say, okay, you want to call an HTML method? Okay, I'm going to generate an HTML tag. You want to generate, I receive a head and a title method. Okay, I'm going to generate head and title tags. Notice also that the blocks of code delimited with curly braces are actually closures. So it looks like just blocks of code here. Here you can also see that we can pass named arguments, so you'll be able to pass attributes to the div tag here. And what's nice is how those method calls, either taking a closure or taking some value, etc., how those closures are nested within each other, which shows the same level of nesting as in the resulting HTML or XML content. So visually, you see the very same indentation. And what else to say about it? Yeah, and you can write arbitrary tags, so it's not just the HTML tag, but you can create your own tags, basically. And this is a dynamic feature, but we can also make statically type check builders as well. But this one is typically a dynamic one. And also something, we kind of relaxed the syntax of the language compared to the Java grammar, in the sense that when you have chained method calls, like this is the case, but we'll come back to this example later on during this presentation, we can drop dots and parentheses, which allows you to write plain English or Spanish or French sentences, because it looks just like English. Here, move forward at 3 km/h. Perhaps the sole difference with what you would have written on a piece of paper is the dot here, but it's a trick here to add properties to number, thanks to, again, the fact that Groovy is a dynamic language. Yeah, so there's supposed to be an animation, never mind. And thanks to the conciseness of Groovy, because we try to simplify Java as well, following certain convention. Here is an example of a Spring Boot application which fits in the span of a tweet. So this is a REST controller, a hello world kind of application in just a few characters. So for those who are familiar with Spring Boot, you can run that kind of Groovy scripts from the command line directly, and you have a hello world web application in just a few characters. So conciseness is also important, because the more concise your code is, usually it's easier to maintain because you've got less code to read and update. Groovy is also pretty successful. That's last year we had 3 million downloads, and the previous year it was 1.7, so it's still going on and growing. I don't yet have the figures for 2014, or at least not the full figures, but the trend is still going strong, so it's a very successful open source project. You can use it in various scenarios, so it's great for scripting, like on your machine, on the command line, if you want to go through your file system and deal with certain files, etc. You can easily write something written in Bash or in Ruby or Perl or something like that. You can do that in Groovy. Also leveraging the wealth of Java libraries available. One use case which is quite common is people embedding Groovy in their applications for business rules. And since Groovy is pretty flexible and provides a rich API for integrating Groovy in let's say Java applications, it's very easy to create business rules, domain-specific languages, etc., geared towards a special the special domain of an application. And I believe that Groovy is really the language which provides the most seamless interoperability and integration with Java, in the sense that you could very well have a, let's say, Java interface implemented in Groovy, then you extend that class from Java. You can mix and match Groovy and Java together. It's pretty much transparent. And it's used by a lot of companies, so I just listed some of those that I know. All these guys and many others are using Groovy in a way or another. Now, let's go more concretely into some of the cool aspects of the language and a quick introduction to how to make your code, your Java code, more Groovy. So as I said, most Java code is also valid Groovy code. So that's why sometimes that's why I quote myself in this slide, that any Java developer is also a Groovy developer, in the sense that when you learn Groovy, initially you usually write Java-like code, but as you learn Groovy, you're going to write more idiomatic Groovy code. And because of the familiarity with Java, how close it is, it's pretty easy to learn. So I was looking for a flat learning curve, but the sole curve that I found was a flat curve when you're dead, but hopefully you won't die by learning Groovy, don't worry. So let's start with something. This is a Java class on top, which with a main class, main method, which is printing hello. That's what. And this is actually also a valid Groovy program. But since Groovy is also good at scripting, and it supports the concept of scripts, it doesn't require to have a full-blown class surrounding your statement. So you can just do println hello, and that's a valid, and that's going to print and have the same result as the Java class improve. But there are things we try to simplify, or some conventions we try to follow, with various things which are optional, like semicolons, parentheses, etc. Let's go through them with this example. So this is a greeter Java bean. So you see an owner field, private field, with a getter and a setter. You also see a greet method, which takes a parameter and then does some string concatenation with the name and the owner. Then later on, you instantiate the greeter, you set the owner, and then you print the greeting message. So this is this is a Java class basically, and this is the kind of Java code you would have in a, let's say, in a main method to use the greeter class. So now let's remove semicolons. So initially, let's say it's a Java class, we just renamed the file from Java into Groovy, that would run just the same. Now you remove semicolons, that just works the same again. You can also remove parentheses. So for instance, you can remove them with the println call or the set owner call. The last thing, the last expression which is evaluated at the end of a method is returned by default. So you can also omit the return keyword. Next, since a class you want it to be used, so by default you want to make things public. So those public methods and the public modifier on class, you can also remove them. So you have public here and there, the three publics which are removed. Groovy supports optional typing, which is the fact that you don't have to repeat yourself all the time, because in the line greeter equals new greeter, you're really repeating greeter way too much. So you can use def, and that's def greeter equals new greeter. And when you use static type checking, which I haven't shown yet, it does type inference, so it knows that the greeter variable, even if you set def, is actually of type greeter. Excuse me. In the last call here with the println call, you can use the shortcut that we saw earlier. So you can say println instead of system.out.println. Something that I'd like to see in Java 9 or 10 someday is support for properties. With the Java beans convention, you have a field, you have a getter, a setter, etc. But often getters and setters are, plain stupid. They don't do anything special. So they could be generated, and that's what the Groovy compiler does. So instead of saying private string owner and getter and a setter, you can do string owner, and you remove the getter and the setter, and that's the Groovy C compiler, which is going to generate the getter and the setter for you. Another thing, so when a field here has no visibility modifier, that's the convention for the Groovy compiler to generate the getter and the setter. If you want the package scope support, you would have to use an annotation. That's one little difference with Java here, in the sense that for having package scope, you have to use an annotation. Then still about properties, you can access and set the owner by doing .owner equals Guillaume, just as if you were somehow accessing a public field, although it's not a public field, but that's the same notation. And you can also use named arguments. So if you pass a named argument inside the constructor here, it's going to create the new greeter with the default constructor, and then in turn it's going to call the setOwner method. So this is really equivalent to the previous difference. And we have interpolated strings. So instead of saying hello plus I am plus etc., you can use those placeholders with dollars to interpolate the name and the owner. Now, if you reformat that, yeah, so the Groovy equivalent is below. You can see that the Groovy version is 2, 4, 6 lines versus 2, 4, 6, 8, 10, 11 lines for the Java version. So progressively, as you learn some of these tricks, your code will become smaller as well, more concise. Groovy's got native syntax constructs that Java doesn't have. So I mentioned closures already, but we have things like list literals, map literals, regular expressions and patterns. You can, oh, there's an equal missing here. Range notation with the double dots. So let's have a look at that. Okay, so the bubbles should be showing up as animations. So we have functions as first-class citizen of the language. So a closure is really just a block of code to which you can pass parameters. So you have parameters here, and you've got the arrow indicating the body afterwards, the body of the closure. So here I have 2 parameters, and I'm going to return a plus b. And I can assign that into a variable, and I can pass that variable as a parameter to a method, for instance. And then, just like a JavaScript function, if, for example, or a math function, you can call the function by just saying, okay, adder, the name of the variable, and then the parents, and pass the 2 values, 1 plus 2 equals 3. Well, I didn't use typed here because I'm leveraging the dynamic nature of the language. And notice that I can also add 2 strings together, and that's going to do concatenation. Groovy supports operator overloading, so you could even have, let's say, a point class or a coordinate class, and you could add vectors, etc. together if you have a PLUS method, because the operator overloading is just a convention, a name convention. If a type has got a plus method, you can use the plus symbol in your code. You can do operator overloading that way. The previous example didn't have types for the variable, but you can also say int A, int B if you want to be explicit. There's an implicit variable that we call it. So instead of saying a arrow a times 2, you can say it times 2 directly. That's the default implicit parameter of closure. So if you just pass 1 parameter to a closure, you already have an it parameter available without having to declare it. So again, I'm calling that closure. And since Groovy adds a multiply method on strings, if you multiply a string by a number, it's going to, by an integer, it's going to duplicate the string as many times as the number. So if you multiply a by 2, you're going to repeat a twice. Here we have the ability to use the varargs notation, so 3 dots or int 3 dots if you want to use the type, and then you can pass 1, 2, 3 parameters, how many parameters you want to share to pass. Another thing which is useful for closures, but as well as for methods, you can also have default values. So here B has got a default value of 10. So I can say mult 2 and 3. So 2 will be in A, 3 will go into B, and 2 times 3 equals 6. But if you pass just 1 parameter, 5 will go into A, but since you didn't specify B, B will be 10, so 5 times 10 equals 50. and in school, in this presentation, you can revise your math from school. Another little trick with closures that's a bit like method references in Java 8, but here that's creating closures. You can get closures as somehow pointers to existing methods. So you can somehow wrap a method by getting a kind of pointer over here, the log10 method from the math class. So I have a log base 10 variable which holds actually a closure which calls math log 10. So I can call it afterwards in the absolute statement. And I did also the same method reference, the same method pointer on the println method, so that I'm able to put that again in a variable and pass that around. Next, how do you see? Yes, it's not. So I usually show this stuff lines after another. So here I have a person class, and I'll come back on this annotation, attributable. We'll speak about it a bit later. So here I'm creating a person with a name and an age. So this is, so we often call that a Pogo plain old Groovy object, because as we mentioned a bit earlier on, this is going to generate a getter, a setter, a private field, etc. So we've got a person class, and it's actually an immutable person, and we'll explain how we can transform the code thanks to annotations later on. I'm creating a list of persons with this notation, the square brackets. I create 3 persons, and then I'm going to find all the persons from that collection whose age is below 18. So that's my 2 daughters, Mario and Erin. I'm going to collect their names and put their names in uppercase. So here I had, in final, I had a list of persons. Then on the collect line, I actually have now a list of strings, a list of first names which are in uppercase. Then I'm going to sort those names, and then I have a reduce operation which is going to join those strings together to give this result in the end, Erin, Mario, in the string. So you notice the find all, collect, sort, join methods, which are very useful methods, and we've got tons of other methods like finding the minimum or the maximum in a collection, like grouping by elements by a certain criteria. For example, I could group by the persons per age, so I'd have a map of with the keys would be the various different ages, and then a list of persons with that age, etc. The head tail kind of stuff, like in the we often see in functional algorithms, etc. Or if you want to create permutations, subsequences, etc. There are tons and tons of useful methods to do functional programming. And by the way, speaking of functional programming, there's edx.com, which features Eric Meyer, who's doing a functional programming 101 course. And I'm helping them translate all the examples and quizzes in Groovy. So if you want to do functional programming and learn about functional programming, I encourage you to have a look at that course, which started just last week. So it's still time to have a look at it if you're interested. Here we have another interesting use of closures with this example. Although file, is a Java IO file is a final class, Groovy decorates, thanks to the GDK, the Groovy Development Kit, decorates the file class with a new method, which is with reader, and another one with writer. Those methods take a closure. And what's interesting is that we create a new reader for that file. We create a new writer for the second file. And when you exit the closures, once they have executed, all the resources will be freed and released, etc. So it's a nice way of and we have that kind of support as well for the SQL support, for what else? Other things where you have to deal with opening a stream, closing the stream, creating a transaction, committing or rollbacking if there's an exception, etc. You can wrap that logic behind a method, and the body of the closure would only contain the real logic with what you want to do inside with that resource. So here, so I create a reader of the first file, and I create a writer of the other one. I read each line of the first file, and if one line matches and contains the Groovy string, I'm going to output the line in uppercase back into the writer in the output file. So here I'm really nesting the closures, and it's really taking care of dealing with the resources. A couple of words since Java 8 introduced lambdas. So here above you have examples in Java. So you create a range of ints, and for each you're going to print them. In the other example, you get the lines of a certain file. You transform the line in uppercase, and then you print them. Although Groovy doesn't have the lambda syntax, you can actually pass Groovy closures wherever you would pass a Java 8 lambda. We've got the same coercion mechanism which transforms a Groovy closure or lambda into a functional interface. So all the stream API from Java 8, you can use that easily from Groovy by just using the notation of Groovy closures. Some more words about closures. There's a nice little trick here. It's a convention, a particular aspect of the Groovy syntax, in that if a closure is the last argument of a method call, you can actually put the closure outside of the parent. So instead of doing unless 10 less than 9, comma, the closure, and then you close the parent, you can actually extract the closure and put it outside, so that if you look at this, unless a Boolean expression, then you do something. So it's like the if statement, but it's called unless. We created somehow a new custom control structure. So it's pretty handy, and sometimes you can see in some libraries things like if you do behavior driven development, you may see given a closure, when a closure, then a closure, etc. You can really create your own custom control structures, which is quite elegant, and particularly for DSLs, domain-specific languages. We already saw an example of list here with the list of persons. So list is just comma-separated elements, and you've got square brackets around. We've got the left shift operator, less than, which appends stuff to the list. So we already saw the find all collect methods for map filter reduce style with closures. We have maps, so that looks a bit like list, but you've got key column value, comma key column value. You can use the property notation map.daughters, or you can use the indexed access. So it's like JavaScript. JavaScript does the same thing. You can do map square brackets and the name of the key. So those two are equivalent. You would prefer the second one if you want to pass the key as a variable, or if the key has got characters which are not valid Java identifiers, you would probably use the second notation. We have regular expressions. So the first line above creates a pattern. We have a match operator with double equals tilde, which is going to return true if the string matches the pattern. We've got the find operator, which is the single equal tilde, which returns regex matcher, and then you can retrieve the elements. So Superman is the whole match, the whole string actually, and the whole regular expression, and super is the first group of this pattern. The last few lines are perhaps even more interesting. You can find stuff. You can find elements of a string thanks to a pattern. So I can extract the zip code, I can extract the city name, and they are automatically passed into the closure as parameters. So that's a nice way of retrieving elements of a string thanks to a pattern to match the various elements you're interested in. Ranges. Ranges are denoted with the double dot, or you can also create a range with double dot less than. In the first case, the upper bound is included, so it's A included up to Z. Here it's 1 up to 9 because 10 is excluded in the exclusive case with double dot less than. Near the end, you can also do reverse ranges. So the range on the bound on the left can be bigger, higher than the bound on the right. And at the very last line, one thing which is interesting is that notice the -1 index. If you use negative index, you're going to count the elements starting from the end. So if you do reverse -1, it's going to retrieve the last element of the range. And the last element of that reverse range is 0. Strings, so we already saw our interpolated strings a little bit. So when you use the dollar placeholder notation. If you create strings with single quotes, that's a plain Java long string. But if you use double quotes, and here in this case I'm using triple quotes so that they are multi-line. And then they can either be plain Java long string if there's no dollar notation in there, or they are G-string, Groovy length G-string instances. But whenever you pass a G-string to a method taking a string, it's going to be transformed into a string when it's needed. So this is an example of doing a poor man template. But Groovy also has a proper templating module as well. So a little quiz. I'm going to use this picture to hide the results. When you do system out println 2 0 minus 1.1, it's actually not going to return 0.9, but 0.8999999. This can be a bit strange for any sane person without a software background, because what you learned at school, 2.0 minus 1.1, that should be 0.9. Similarly, when you do 3 divided by 2 in Java, it's going to be 1 because we do integer division instead of being 1.5. But actually, in Groovy, when you do 2 0 minus 1 1, it's 0.9, and 3 divided by 2, it's 1.5. Because by default, when you use literals with dots, number literals with dots, it's actually creating a big decimal. It's not a float or a double with the imprecision that comes with them. So we have the exact and correct results, and we don't use integer division by default. So that's why sometimes people think that Groovy is slow and when they do micro benchmarks, because they don't necessarily know that by default Groovy uses big decimal. But if you want to use a double or float, you can create a double d equals 2.0 variable. It will really be a double, not a big decimal. Or if you use some suffixes like 2.0d 1.1f, you would create a double or a float. But this feature, although it might be surprising for us doing Java, C, or most mainstream languages, this feature is actually something that was very much appreciated by financial institutions, banks, insurance companies, and others. And they often decided to use Groovy because of the fact that by default those floating point numbers were big decimal, because when you're creating financial applications, you'd better use big decimals if you want to have accurate calculations without rounding errors, as you would get with doubles and floats. We've got a more powerful switch case. So in Java you can use numbers. Since Java 7 you can also use strings. But in Groovy you can also use classes. So here the first line, okay, is the object the number 1, 2, 3? Is the object the string ABC? Or in this other case, is the object an instance of string? Is the object a member of this list? Is this object to string representation is matching this regular expression? Or you can create custom conditions if this object matches the result of this Boolean expression here inside the closure. So we have some powerful switch capability, which is also helpful when you want to do pattern matching. So it's not full pattern matching, but it's part of the of what you can use to do pattern matching in Groovy. If you remember the, I think I've got the other example afterwards. If you remember the example from the introduction, I'm going to show it in the next slide. I mentioned that you can get rid of some parents and dots, and here I'm showing how you can remove parents. So actually move parents and parents at the end, between move an object and a parents at the end. You can have a call with a normal argument or object, and then you have named arguments, x colon 3, y colon 4. You can mix both together so as to give more visual cues as to, for instance, what this number is. Is it the x, is it the y, etc. That can be pretty helpful. And there's a call convention, which when you have named arguments and normal arguments, all the named arguments are actually passed as key values in the map, and then all the normal arguments come in the order as they are defined or passed as parameters of the method call. So that's helpful for creating nice DSLs. Again, I mentioned that you can remove dots and parents when you do chain method call. So remember this example from the introduction. This is actually equivalent to move, a move method which takes forward as a parameter, on which you're going to call an at method on the result of the move forward call. And at takes this expression 3.km/h, which is actually a shortcut for 3.getKilometer. We're using the property notation, but somehow Groovy allows you to add properties or getters or methods onto numbers. With operator overloading, the slash for the division is equivalent to the div method, and h is probably a time unit constant represented in 1 hour. So it's very nice for creating your own readable French-like, Spanish-like, English-like sentences in your language. And then if you mix named arguments and command chains, that's when you drop parents and dots for chain method calls. It's funny because visually you have the impression that there's a break. You've got check that, vodka tastes good in 2 parts, but actually the parser will understand that as check that vodka, that's a named parameter, and the result of that call you're going to call the taste method with a good argument passed to it. You can do multiple assignments by using that notation with the parents around A and B. You can do a swap by saying A and B equals the list B and A. You can also specify the types. If a list returns, if a method returns a list, you can also use multiple assignments to retrieve the elements of the list. So if you want to retrieve the first coordinate, the second coordinate, the latitude and the longitude, you can do that. And you can actually implement your own destructuring You just need to have a get@, method, which takes an index, and that way, I'm showing that in the second line starting from the end. X and Y will contain the values of the X and Y properties of the point class. You can create your own way of doing destructuring by using multiple assignments and the special get@, method. Oh, well, you don't see that, so let me show you that first. This is a feature which is using the dynamic runtime. This is like the markup builder from before, but it's for in the JSON module. You can actually have the same kind of builder as the markup builder to create JSON content. So here, this one is going to actually create this payload here, person, name, age. And notice that when I pass several values, so you don't see the values there. Marion, Erin, I pass several values. It's going to create a JSON array, etc. So that's nice for building JSON. But there's also a slurper, a parser for JSON, so you can also consume JSON content. This example is quite powerful because in just a few lines of code, you're really doing something which is non-trivial, I would say. So here I have the URL of the GitHub REST API. I want to retrieve the list of the latest commits to the repository. So I have a string. Groovy adds a toURL method on string, so it's going to transform the URL. When you see URL.toURL, it's going to return a URL out of that string. And then notice the .text, which is a shortcut for getText, the getText method, which is going to do an HTTP GET, RESTful GET call on that remote URL to retrieve the content. So you don't have to fire your own URL connection handler. You don't have to use another library. You can just do .text to do an HTTP GET over a remote resource. So that's really powerful. And then you didn't have to create the same structure with POJOs as the JSON content. But thanks to the fact Groovy is dynamic, you can retrieve elements of JSON arrays. You can find the commit property, the author property, the name property out of the JSON content without having to create intermediary Java objects to represent the various elements of that JSON graph, that JSON payload. So that's very powerful. And you can also mix and match find all, etc. in that kind of expression. So we sometimes call that GPath. So it's a bit like XPath, but for arbitrary structures, whether it's an object graph, JSON graph, an XML graph, etc. So with that notation, which is just like if you were navigating the object graph, but it's done dynamically because it could have any JSON content, but you wouldn't have to create the intermediary Java objects to represent that. So there's in Java we have asserts, but asserts are disabled by default. But in Groovy, assert is enabled by default. What I want to show you here, I have is the what we call power asserts, which have been introduced and created in the Spock testing framework, but have been adopted by the Groovy project as well. When you have a complex expression, if the assertion fails, it's going to show you a nice assertion message, which is going to say and to give the actual value of each sub-expression. So you can see the value of b. The value of b minus 1 is 29. The 20 times 29 is 580, etc. And you can see the value of each sub-expression. So you don't have to do 10 different asserts and local temporary variables. Very easily you can spot what is wrong in a complex expression without having to do several smaller asserts or that kind of thing. That's very handy when debugging, when trying to find errors in your tests. Okay, so this one is a bit overcrowded. Let me remove that, and I'm going to explain. Up. So null handling. Let's say you have an order class with line items. The line item has got a quantity of items, and an item has got a name. If you create a new order with one line item with two items, but notice that the item is null. If you do in Java o.getLine.getItem.getName, which is a bit shorter in Groovy if you do o.line.item.name, what happens when you call the last dot name, you're going to get a null pointer exception because the item is null. So when you call name or null, it's going to throw null pointer exception. But in Java, null pointer exception is not very meaningful because it just tells you null pointer exception on line 12 or 13 or whatever. It's not telling you what is null. In Groovy, this is different. In Groovy, you would get you would also get a null pointer exception, but there is a message, and the message says cannot get property name on null object. So you see very easily where what was null. So you see name, okay, that was item, that was null. So you can easily spot the null pointer exception. Then in Groovy we also have a specific notation with the question mark dots, which allows you to when you use that throughout this expression, whenever something is null, the result is going to be null of the whole expression. So instead of doing if O different from null, if O dot line different from null, if O dot line dot get item is different from null, etc. You don't have to nest if together. You can just do O question mark dot etc. to get a null value when something is null in that chain. Another interesting thing is what we call the Groovy truth, and also the fact that you can even customize the truth in Groovy. So everything that is null, empty, zero side, or equal to 0 has got an equivalent Boolean value of false, and otherwise everything else is actually true. An existing object is true, a non-void string is true, etc. And what's fun is that, so all the, let's say, if, while, what else, assert, etc., all the methods taking a Boolean will leverage that convention and will coerce an expression into a Boolean value following that convention. And what's fun is that you can also customize that truth yourself. So you a Boolean expression if you have a Boolean as Boolean method. And here an account evaluates to true if it's a valid account, or it evaluates to false if the account is disabled. And here is the Elvis operator. So you already saw the safe navigation operator with a question mark dot. Here, this is question mark colon. And if you put your head on the side, it looks like an Elvis smile. Basically, the Elvis operator right at the bottom is actually somehow shortcut for the ternary operator, but it's doing a bit more because it's leveraging Groovy truth. So what it's doing here is if x is not null, if it's of size more than 0, then we're going to use that value x. So that's what's going to be returned by that expression. Otherwise, if it's null, or if the string is of 0, we're going to return y. So this is a way of default value operator, because it's either x if it's not null, or you provide the default value, which is y. Groovy has got AST transformations, that's code transformations, which transform the code when it's in an in-memory representation in the compiler before we actually generate bytecode. So that means we can hook into the compiler, change the representation of the program before it's compiled to bytecode. And we've got tons of transformations. You briefly saw in short one, but there are many useful code generation transformations, for instance, for generating a toString method, or creating a builder, not a Groovy builder, but the Java Fluent APIs kind of builders. We have what else? If you want to use type checking and compile static compilation, it's actually triggered also by an annotation, which is built as an AST transformation. And let's have a look at one example, which is immutability. If you want to implement immutability by the book, like in the effective Java book, there are many things you want to do. So you have to make the class final so that it cannot be extended. You should provide a tuple style constructor to pass all the values of the fields, of the final fields, and to be final so that they cannot be modified. If you have properties which are collections, you should collections when you return them with the getter, because you don't want someone to change the value inside the collection, etc. And if you want real immutability, two similar objects should be equals and have the same hash code, etc. So it's actually quite a bit of code to do that properly. If you do that in so for a person class with just a string name and int age property, it can be quite long and verbose to do that with private fields, with proper equals methods, etc. So although this this example it's in Java, but it's also valid in Groovy. But in Groovy you wouldn't write that. Instead, you would write @immutable class person string name int age, because the Groovy compiler is going to do the job for you, and it's going to generate all the implementation of equals, hash code, etc. So it allows you to write much more concise code, and you won't make an error in the implementation of the @immutable, the immutability pattern, because that's the Groovy compiler which generates proper code. So you wouldn't get bugs in those parts. Another example is the memoization transformation, which allows the compiler to actually cache and the runtime as well, to cache the value of the computation of previous invocations of a method. So if you annotate the Fibonacci method with @memoized, it's going to remember the value of previous invocations of Fibonacci with the same parameter. So instead of Fibonacci 40 calling Fibonacci 39 and 38, and then 39 calling 38 and 37, you see that Fibonacci 38 is going to be called twice, and then Fibonacci down the chain, Fibonacci of 1 will have been called perhaps 40 times, etc. So we cache the value and return the value from the cache, and that's a code transformation which implements the pattern of memoization, of storing and remembering the value of previous invocations in a cache. So the nice things about transformations and code transformations in Groovy is that they allow you to be lazy, because Groovy implements many of those patterns, etc. for you. That's really the compiler that does the job for you. It makes your code more concise and more readable, because there are less lines of code to maintain and worry about, because that's the job of the Groovy developers to write the transformations properly. And two of the other transformations are type checked and compile static, for static type checking and static compilation. And it's pretty powerful. So compile static builds upon the feature. And we do type inference. We do pretty clever tricks, and the type inference is way more elaborate than the type inference that you can see in Java, actually. And you can even extend the static type checker with your own rules, some Feinberg rules or check style rules, etc. You could even create your own extensions to do to check some properties in your code. And to check DSLs, even with dynamic features. If your tag checking logic understands the DSL, you can do pretty advanced stuff. But I'm not going to dive into that because that's worth another hour of presentation. And static compilation, so builds upon generate pretty much, makes the Groovy compiler generate pretty much the same bytecode as JavaC to give the same performance as Java. So I had an old benchmark that I haven't updated recently with an old 2.0 something version. So the figures should be a bit better. So I'm showing some micro benchmarks, which were the worst micro benchmarks for Groovy, showing it in the less nice light possible, showing the worst possible performance for Groovy. Very old versions of Groovy, you notice there could be a huge gap in terms of performance, really an order of magnitude difference, but with different techniques like primitive optimizations when you do a primitive calculation, and other improvements we've done over the various versions, and also since the 2x versions of static compilation, you notice now that you can have the same performance between Groovy and Java. So there are sometimes, perhaps this one now is closer to Java as well, and but you can get pretty much the same performance as Java when you use static compilation in Groovy. For those places where you don't need particular dynamic features, which are forbidden when you use. And beyond that, Groovy, the language, Groovy, the API, Groovy, the SDK. We also have a very nice community, pretty blossoming ecosystem. So we started with a Groovy project in 2003. In 2000, when was that, 5 or 7, we created the Grails framework for building web applications. We have Griffin framework for building rich desktop applications. The Gradle build automation solution, and we have many other interesting projects like the Spock testing framework, CodeNarc, which provides static code analysis like PMD, check style bugs, etc. Jeb is for web automation, etc. I'm going to mention a few of them. GVM, the Groovy, that's a command line tool which allows you to install different versions of different frameworks and libraries. So there's a command line to install the various versions of Groovy, the various versions of Rails, of Gradle, Vertex, etc. So it's a command line tool, and I often use it myself to check if a bug exists in a version of Groovy or another, or if I switch between projects using different versions of Grails, etc. That's pretty handy. We've got the enterprise testing framework, Spock. So you saw an example earlier. So here I'm grabbing the dependency, so you don't need to create a build file to execute that script, that class actually. So well, that's pretty much the example I already mentioned in the introduction, but it really makes for nice tests. And @grab is actually an HT transformation which adds to the class path dependencies, like the dependency on the testing library here. We've got the Ratpack framework, which is an AT-based web app toolkit with some nice routing capabilities, and which is also implementing the reactive stream interfaces, etc. It's a pretty efficient library for doing reactive programming. Jet, that's for a browser automation. You can drive a Chrome browser, a Firefox browser, or even an HTML unit fake browser. So when you want to do scripting, scraping of website, or automating, clicking on a form, etc., you can do that. And you can mix that with within your tests. So this is an example here. If you it's a nice DSL as well for driving the browser. So you drive the browser, you say go to this URL. There's a jQuery-like syntax for getting through the HTML. So you can retrieve the content of the H1 tag. Then you can retrieve the form, filling the values of the form, click the login button, etc. And then you can also mix that with a Spock test and Jeb page objects. So they are not defined in this example, they are defined elsewhere. So you can say, given you're going to the Google homepage, then search for Wikipedia, then wait for being redirected to the results page, etc. Well, we're coming to the end. In summary, Groovy is Java's best friend in the sense that it's very easy to learn because it derives from the Java syntax, but it goes beyond Java in terms of syntax, conciseness, expressiveness, etc. And the various conventions and shortcuts and closures, etc., make it a nice fit for domain-specific languages when you want to have rich business rules in your application. It's providing the best and most seamless integration with Java without any barrier between language, so you don't have to transform the Java object into Groovy or a Groovy object back to Java because they are really the same thing in the JVM. Groovy is a multi-flavor language. It's an object-oriented language, dynamic language, but it can be as type-safe or as fast as possible with static type checking, static compilation, and also a functional language in the sense that you have closures and all the MapReduce API on top of collections, or you can even use the streaming API from Java 8, etc. And it's used in various contexts for business rules, task or build automations. For testing, sometimes companies introduce Groovy in their companies, in their teams through testing or through the Gradle build. But you can also use Groovy for full-blown applications when you want to build web applications, desktop applications, etc. So that's it. So thanks a lot for your attention. I guess we can have a question if we want.
Yeah, well, Guillem, we would like to thank your explanation about Groovy, because I think it was really great. It was really interesting and really easy to understand all the key concepts behind Groovy. I think it's really easy to apply to start using Groovy, and that's my first question is related about why the Java developers are not using Groovy right now. I mean, what do you think is the distance between Groovy developers and Java developers? Why the people is not using Groovy right now?
Yeah, so when I look at the download numbers, I can extrapolate that there are several 100,000 Groovy users, so up to perhaps up to 400,000 or 500,000 Groovy developers or users. So compared to the 10 million Java developers, well, that's still significant, but obviously Groovy is not in everybody's hands. So what is that? Well, you know, Java is really very widespread, and I guess people are always more shy to use another language. I was going to say a new language. It's not really new because it's already 10 years old. But they, I don't know, it's not necessarily backed by a big company like Oracle, so they might have some fear of change, etc. But there's really a big crowd of people actually using Groovy, several 100,000 developers. So that's a significant number. But well, that would be nice if there were even more, of course. Yeah.
Okay. I understand. We have a few questions. I think the people
Yeah.
are talking to us in the other channels, so I will try to ask you. For example, that people, the guys are speaking about talking about what about the super of enterprise stuff? I mean, JPA, CDA, and the use of Groovy. How does this
Right.
work? I mean.
So, I mean, since we've got a great interoperability story with Java, I can you can use JPA, you can use CDI. There's really no problem with that. And your code might be shorter and more concise because it is Groovy. So you can really use JPA, CDI, etc. We don't add particular syntax sugar on top of that per se, but if you look at things like Spring Boot or Grails, etc., they also have their own take on enterprise applications. And if you look at Boot and Grails, for instance, they show you how you can use JPA under the hood to query a database, etc., or Spring for dependency injection, not necessarily EE, but Spring's dependency injection in a pretty elegant way. So I invite you to have a look at that. But otherwise, there's nothing preventing you from using JPA and CDI from Groovy.
Okay. We have another question related with OSGI. We have a few lovers of OSGI here in Barcelona. And we have two questions related with OSGI. The first one is the super of the OSGI environment, and another one related with the super for Apache Camel.
Okay. So Apache Camel actually has got a Groovy. I don't know if it's a module or I don't know exactly how it's working because I'm not very familiar with Apache Camel. But there's definitely a Groovy support in Apache Camel. So if you want to define, the roots, etc., you can use Groovy scripts for that. And in terms of OSGI, the Groovy jars, the various jars that we provide, actually have the right metadata information for OSGI, so they are OSGI compliant bundles. So if you want to use OSGI Groovy in an OSGI context, you can do that. Yes.
Okay. Cool. And I think we have another question interesting about the polyglot programming between Java and Groovy. I thought that you can switch off working with Java and Groovy, and seems that it's transparent. It's true. I mean, it's that as far as easy to work in a Java environment and work in Groovy environment.
That's one of the things I didn't mention. So I said, you can have a Java interface implemented in Groovy, then you extend that Groovy class from Java. You can do that kind of thing. What I didn't explain, for example, is we have what we call a joint compiler. And it actually it actually combines both Java and Groovy together. So that's why it allows that kind of setup of circular dependency between languages. So it's nice for the integration because for certain parts of your application you may want to develop it in Java, or because it was developed in Java initially, but then, oh yeah, the JSON support in Groovy is super cool and it's super fast, by the way. It's even faster than JSON or Jackson, etc. You could decide, okay, I'm going to use the Groovy JSON support because I don't want to create Java objects representing the various elements of JSON payloads. And then, yeah, I mentioned there's no barrier between languages because Groovy object is just like a Java object, and when you use a Java object from Groovy, you don't have any conversion to do. But some languages, for instance, JRuby, you have a Ruby object and you have a Java object, so you have to switch somehow between the two. So we don't have such barriers. And what else? And well, it's not really bad integration, but I mentioned how the syntax of Java and Groovy were pretty close. So that also helps when you want to mix and match Java and Groovy together.
Okay, and I don't know if I have more questions, but I think I have one related with the performance. I mean, as far as I know, Groovy creates a kind of meta model around a class, and then how does this affect in the sense of the performance in a Java application? I mean, maybe it's something weird, or there's nothing more magical than adding a proxy service or a proxy client or a proxy class.
So it's totally transparent when you use that in your application. So the method invocation, especially at first, might be slightly slower, but in fact we have various optimization techniques that are involved, which are actually caching which method was called at a certain call site. That's the place where one method invocation is being made. And if you use also the JDK 7 version, we also use invoke dynamic, which also does a similar approach with caching how a certain method is chosen at runtime, and it gives pretty close to Java performance even for pure Groovy dynamic features. So that's in terms of performance, that's not very noticeable. And usually, I mean, sometimes people say, okay, I'm going to use this language because it's supposed to be faster, etc. Or dynamic language. All dynamic languages are slow. This is pure bullshit, because most of the time in your application, you're going to wait for I/O, for instance, for accessing data in the database, or a resource over the network, etc. And all those things completely dwarf any slight difference you might have in method invocation time. So it's not very significant. And when you don't use a particular dynamic feature, you can use static compilation, and you get the very same bytecode, pretty much the same bytecode as Java C when it generates. So you get the same performance as Java for those parts where you really don't need any dynamic aspect of the language. So Groovy is really the fastest dynamic language, and as fast as Java where it's needed, basically.
Okay. We are finishing the questions, and I think we have one of them related with the cache and memoization. I think we talked about. It was focused on how the memoization process allows you to specify a kind of lifetime of the cache.
Okay. Yes. So there's a least recently used cache which is being used by default. So I don't remember if we have parameters. I'd have to double check on the annotation. But for instance, I remember for the closure variant, we also have memoization going on for closures as well. You can say memoize at least a certain number of values, or at most a certain number of values, and so you can resize of the cache, not really the duration. You don't have control over that. But also, what's interesting is that when there's the garbage collector coming and there's a big need for more memory, the cache is actually using soft keys, weak values, etc., in order to the memory of the cache to be reclaimed when we're running low on memory. So you can control somehow the size of the cache, and don't be afraid of the size of the cache, because when memory is actually needed, the cache will be flushed anyway.
Okay. Okay, cool. And the last one I think is related with the GPath. You speak about how to navigate the JSON, and I think someone understands that you will not know if everything works or not unless you run that line. So it seems that it will throw like a runtime exception, and if your Groovy syntax is okay, but you don't know everything until you run it, seems strange.
Right. Yeah. But well, usually when you call a REST some REST endpoint, there's usually some documentation saying what you can expect in terms of payload. But yes, if you make an error, a typo, etc., it means that at runtime you would get it will say property not found, or method not found, or something like that. So you'd get an error at runtime. Yes, if you make an error, if you didn't check the schema of the REST endpoint of the JSON contents. So it's indeed runtime. Yeah.
Okay. Okay. I don't know if Alex or Jonathan or any of the other guys that are online has any question, but I think we are finished.
Okay, cool.
Okay, so thank you
Thanks a
for
lot, guys. Thank you.
thank
Thanks
you.
so much.
Thank you, and have a good night. Bye
See you
bye.
soon.
Thank you all.
Thank you. Bye bye.
Bye.